As a first presenter. He's our first presenter. That's tourists. Yeah, tourists. Tourists. I can't help it. It's great. Yes. Good morning. Oh, there's a funny echo. This starts the roll session. I wanted to start. I want to say that Ines Robles unfortunately is between jobs and couldn't come, but I'm very happy that DJ is here, well known from the group communication drafts that she's presenting in ACE. Thank you, DJ, for assistance. Here is the note well sheet. Please note well. If things go wrong and all the work of the working group goes to nowhere, that would be very, very much regretted. So please pay attention to what is going on. The meeting materials, we have remote Japper and the minutes taker, it's Dominique. Thank you very much. And Raoul was the Jabber scribe. Also, thank you for it. The blue sheets will be distributed a few minutes later. The agenda. Anyone wants to modify the agenda? No wishes to? Very good. Then the milestones. For the moment, everything is green. There is just the proposed document, disflags and options, which is late, and I think it will remain late, so you see later how we have to handle that. But for the rest, there is a very quite green milestones. The active internet drafts, we have the AUDV RPL, which we'll discuss today, the DO projection, which we'll discuss today. There is the forward selection, which is on hold. I don't know when it will go further. It depends on the interest later on. The use of RPL info is in AD evaluation. Maybe you could say a little bit about that.
Hi, Alvaro Rotana, Routing AD. Before I say anything, I've been on vacation for 3 weeks. I maybe forgot half of anything, so this may not make all the sense. Yes, I've been reading this. I am about halfway through the document. There are some concerns that I have around some of the updates. And some of the things are not really clear as to why we need to update specific documents. What do we do with the compression, for example, where the RPI is not specifically signaled, meaning when you decompress, for example, how do you know they're using 23 and not 63 at the other end? So I'm about halfway through there. I'm getting close to the use cases. Which I hope will be a lot faster because it's okay, this use case you encapsulate here and there and go from that. So I'm hoping that in the next, I'm going to say 2 or 3 weeks after the IETF, I should be done with that and be able to send comments back. That's it.
Thank you very much. It's a long and complex document, I think. Okay, then we have the Mipel Young. We will discuss it today. It is one of those young models which are asked for. I hope that there will be some review later on. The beer design team takes over. It will be our first subject for today. And we will have NPDO. Then we have the unaware leaves, which will be discussed today, which is still in private. The ripple observations, which we have called for adoption, has been started. And we have the other private drafts, which will be discussed today. Any questions about that? No? There are open tickets. They will be handled. It has been promised by Pascal. Then we will have the first presentation, and I should like to ask Tourlus. Yes, you're the first man.
All right. So, just a quick update from last time. So, we basically last time Carson and Pascal were presenting their drafts about ideas on using S-strings and addresses in Visual to basically browse packets using custom multicast. And Carson's solution was primarily looking into the ability to compress the experience for the view filters, and Pascal's draft was intended to define a overall framework that does the intersection of both options in terms of create kind of forwarding methodologies in here. One is here, the other one that is proposed is here C, and then visual output. And so here, basically, every bit is indicating a receiver on the network, and here T, the bits can also indicate individual hops along the network. So therefore, potentially allowing you to get into your non-storage mode because you can indicate a hop.
So maybe just to reduce confusion, the constraint cast approach has pretty weird bits in those bit strings because they contain output interface addresses. So a little bit longer than other bits. Longer bits.
There has been a request from Jabber. Can you please speak closer to the mic?
This is 1 micrometer.
Yes. Oh no, that's fine. It's difficult.
That helps. I thought you folks were able to figure that out. Because from here it's, now here too. Okay, cool. Right, so, and then basically the idea was that there seemed to be a lot of interest in the room, and we're saying, okay, let's do a design team. So since then, unfortunately, not a lot of progress. So I got through all the bureaucracy from the IETF with the help of Albro. So we've got a working group mailing list name. So just normal non-working group mailing list with an archive and everything. Got a wiki page on track with the charter that had to be approved by the area director so that you can get the mailing list. But then really not a lot of activity except for me trying to reach out, but didn't get any response then. But I also had, something like more than a month or two where I couldn't do anything. So in the following slides, what I'm going to do is my own analysis, what I did try to figure out. And then at the end, we can see how much more interest there is. So I was trying to figure out what are the most interesting high-level points, because I think Pascal has been doing a pretty good job at the bottom-up stuff in terms of, how could we bring it together from the protocol level, and I have still absolutely no clue about ripple signaling. So on the signaling side, I can't really contribute at this point in time. So let me first talk about Bloom filters, and hopefully Carsten isn't going to beat me to death about it, but I'm trying to be as fair as I understand it, and hopefully, I'm understanding things incorrectly. So the first thing, and maybe is there a way to blacken it out? No. Okay. Sorry, way too much text. This is much more meant for people after the IETF to read. So let me start from the bottom, right? So how in IP multicast would you basically be try to control, 500 lights, right? Let's say every light is, an endpoint on the network. It has associated with it, whatever, IP address or so. In IP multicast, what you would need to do is you form a multicast group, all the lights join to it, you come up with an application protocol. In the application protocol, you would, for example, give every light a bit, and then you basically send down in the application a bit string that basically says, please on these bits, or off these bits. And all these messages would go to all the lights, because that's pretty much the only thing you can do in IP multicast reasonably. So now in Beer, you basically have the bit string at your bloody network layer, if you can do Beer end-to-end up into the application. So you can basically send a Beer packet with the 50 bits set that represent the lights that you want to switch on or off, and you basically don't need IP multicast for it. Now that type of end-to-end Beer, I think, is really the coolest thing about Beer, and we haven't been dealing with that, and I don't think we're still not dealing with it officially in the Beer working group. The chair can update me on that. I haven't been following.
I'd say you're right, and we haven't specifically gone after that with drafts. It's been, Greg Shepard, Cisco, and I'm one of the co-chairs for Beer. But it has been in our sights since the beginning. And finally getting the ether type was that big step in that direction. We've had feedback from countless operators who've said the same thing. We've heard things like, I want to get rid of multicast from data center to desktop. Right. So that is end-to-end. And being able to do that in the stack is a big help in that direction. So there's nothing specifically at the Beer architecture that says it's not end-to-end or that it is inside of a network. Right. But we haven't had a use case to articulate how it would be used.
Exactly. So, and that's basically what I had at the top of the slide. So basically when Beer started, the obvious use cases where multicast was done a lot was basically multicast and service provider, which is just as an underlay for IP multicast. That's why all the standardized work is really focusing on that use case. There is one draft where, we're trying to outline also, to the end, into the host or, application layer gateway, native end-to-end use of Beer and show the benefits of that. So that's mentioned there. So that's really the cool thing about Beer, which I think, way beyond the points of trying to reduce the amount of state because of non-storing mode or so, I think would be cool to think about as being beneficial in the IoT space where Ripple sits, right? Because I would hope that applications like what I was mentioning about, building control and others, where you have group communications and want to efficiently send individual commands to a subset, should be well in scope of really the use cases of networks with Ripple. Okay, what has it got to do with Bloom filters? Well, the Bloom filter is unfortunately not exactly the same bits as the ones you want to address, but it's a superset of them, right? So basically, if you send the Bloom filter, the packet will make it to basically endpoints that are really not set, and you would basically need another layer of really figuring out whether the packet that you received is actually meant for you or not. Carsten.
Yeah, so you just described why Bloom filters probably are not such a bright idea for end-to-end Beer. Mm-hmm. That's not what our draft is about.
Right, but I mean, I'm saying,
Yes.
of course, given that nobody in before brought up the end-to-end Beer, we haven't clearly laid that out, right? So I don't think for most people.
Because you didn't say it. So in the constraint cast draft, the Bloom filter is not for identifying end nodes.
Right.
It's for identifying forwarding nodes.
Sure.
And that's why it's okay that it occasionally has false positives, because a little bit of additional forwarding in multicast forwarders is not going to hurt you very much.
Right. Which is again the question: what is it that we're trying to achieve, right? So, and the Beer working group lives perfectly with use cases that don't do end-to-end Beer. I'm just a fan of end-to-end Beer, and I was just trying to explain the differences and the impact of Bloom filters to it.
Pascal Thubert. The one advantage of Beer in the particular case of Ripple is that storing mode is usually not so successful in small devices because of the amount of state that you have to keep. And using Beer allows us to keep a state per child as opposed to a state per leaf. And that's humongous.
No, understood. I thought that point was already well understood from the last IETF, so I didn't renew that point, right? So that was the very basic one. So the other problem with the Bloom filters, and that's where, I'm not very sure because of missing detailed understanding about ripple and everything. And that is that there is a basic mechanism in the, beer working group forwarding for beer and beer TE, which is about resetting bits. And that is done to avoid duplicates, and it is done to avoid loops. And so obviously, because we're indicating hop by hops, it is more of a problem in beer TE than in beer. So, and I was trying to figure out, how that, I think inability to reset bits along the path when you are doing Bloom filters, if that's my correct understanding, is a problem, right? And so if I'm basically having beer and my underlay that I'm going over is free of alternative path, then it will work perfectly fine, right? Because, as I said, it's only about alternative path and loops. And so basically these rules in terms of, okay, we've got a rank and we're basically through the rank. I'm not sure if through the rank we're building exactly a tree, or if we're building basically something that, has alternative path also.
Where we are building a destination-oriented directed acyclic graph.
Which is tree.
No,
No.
it's a graph. The point here is we didn't have to do loop prevention in constraint cast because we have the rank.
Right, but so basically you go from one node, you go down to other path. Is it possible that basically these paths reconverge at some point further
Yes.
down? Then you will have duplicates.
Duplicates, yes.
Yeah. Right. So, and the problem, of
Duplicates
course,
are
if you have
great
more
in
of
a
these
lossy
things,
network.
then you can get quadruplicates and octuplicates, if that's the right words. Right. So basically, the more of these branch and merge you have in the network, you exponentially go up with the number of.
That's why pretty quickly we added a sequence number that allows a node to actually reduce the number of.
But that would be additional per packet state,
That's
right?
additional per packet state. Again, since we are operating in non-storing mode, we have a place where that can be inserted.
Right. Yeah. So, I mean, yeah. So those basically are the main things that, if you want to update the draft, right, I think that would be good to have as highlights, better understanding, because just from reading the draft, it was difficult to figure out these high-level points for me, right? It's just getting into the, yeah. That's good.
Pascal Tuber. A quick information on Ripple is that Ripple is loopless, not because the DAG is guaranteed to be completely converged at any time. That's wrong. It's never really converged. We don't have a concept of convergence in Ripple. That's one of those things that makes it different from other routing protocols. What protects us from loops is that we get a bit in our frames, which is called the O bit, just like Bilbo. And the O bit is set so that a packet can go up and then down, but once it has been going down, it can never go up again. Right, and that's it.
I'm getting closer to this stuff, so bear with me in terms of, but okay, that's fine. So we, but I think the duplicate that you can get with the Bloom filters, that's certainly a concern that needs to be really understood in terms of whether that's feasible for deployment or not, right? So. Yeah, it's just the quantification of all these parameters, I think, in the end, is going to be fairly multifaceted, which is why at the last slide, I'm going to ask that maybe we come up with some reference cases and really provide, very explicit examples of the quantitative benefit or non-benefit.
I have no idea how to prevent receiving duplicates in a wireless network. There's
No, that's
way
not
to
the
do
point.
that.
That's not the point. I think the point is that the IETF typically doesn't like to create solutions that create persistent duplicates that are not dealt with. You said
There
that
is no way to prevent that. If I have two nodes that are too far away to cover it from one forwarder, I will have two forwarders sending to those nodes. And a third node that is in the middle between those two forwarders will get persistent duplicates.
Okay, maybe let's take it
There's no way
offline.
to
I
prevent
would love to, if we have a good justification that the duplicates are only happening not because of a shortcoming of the mechanism that we have, but because of a dependency underneath it, that's perfectly fine. That's a little bit too long, I think, right now for the mic here.
I think the fun part is how do you process these duplicates? So, of course, IP has a service model that makes duplicates permissible. That doesn't mean that all protocols react favorably when they receive them. That's one observation. And of course, the other observation is if we can put in a little bit of mechanism to reduce the impact of that, that's good. And that's why we came up with the sequence number, which is still local to the path from the root node to the receiver. So it's not necessary to put anything into the hosts to do this.
So, second point, so that was basically about Bloom filter. Now the rest I think is in general about the non-Bloom filter things. So basically repeating the basic point that, you know, the hop by hop would be good to support the non-storing mode. And then the question, of course, is how long do we make the bit string? Pascal came up with crazy numbers, or maybe good numbers, I don't know, right? So definitely not the exponents of 2 that we had in the beer working group, but 160-bit or so. And so defining the size right has been, you know, a big, you know, Greg could talk better to this question going back and forth in the beer working group, because it's based to make it work on ASICs, right? So you make a very long bit string, especially with BRTE, you become a lot more efficient because all the topology bits you only need to allocate once. If you basically make a small bit string, partition up your network, you need to basically duplicate the bits in each of these groups that are in the topology. So you become less efficient with BRTE the smaller it gets. And the other thing is that neither beer nor BRTE have been really optimized and thought of to be used for unicast only, right? That would only come in here and roll when we're saying we want to use it really as, you know, a simple way of, shall I say, segment routing, right? Instead of a hop-by-hop path with a single bits, right? Just for unicast, if we use it that way. So the way I would see it, a good way to deal with that is to recognize these things and then say, okay, for multicast, right? We can have a really, really large bit string. Just compare the band. Let's say, you know, you have 2000 nodes. Okay, let's do a 2000 bit string, right? How much is that compared to sending multiple packets, right? Because you don't have a hardware limitation to look into a large bit string, right? So it's not difficult to figure out the 3 or 4 bits of your adjacencies, or 10 or 20, from a 2048 long bit string, I would contend, on a software node, right? And sure, there is overhead, but how much overhead is that compared to, you know, passing through instead 4 or 5 packets, right? And I think you'll come out in a lot of cases beneficial. I'm looking at you to jump up and contradict me, or not.
Pascal, again, some file layers have, or some Mac actually have limited frame size, like
Okay, sure.
128 bytes. So
Right.
don't put more than that.
Right, but
in the
it's,
string.
yeah. Oh, 128 bytes?
Yep.
Okay.
15.4. 128 bytes.
Right, so maybe there's also another way.
LoRa, 19 bytes minimum.
Right.
But
Yeah.
we
So,
don't try.
so maybe there are also ways around it, right? But then, if we're thinking about unicast, right, I think there is a very simple way to reduce the bit string size, and that is obviously very simply to say, if we only unicast, well, we only need to have bits for the actual topology, not for the receiver node. We just need to have the logic that the last hop router basically just looks up the encapsulated destination IP address or whatever, and basically knows which of his directly connected hosts it wants to send the unicast traffic, right? So if basically, let's say only 10% of the overall nodes are routers and 90% are receiver hosts, then I've just saved 90% of my bits.
Yeah, I mean, that's of course kind of the thinking behind constraint cast, that only the output interfaces have bits which
Right.
they
And in
aren't.
this case, I would say we don't put bits on the output interfaces that are on the last hop toward a receiver node.
No, we put bits on the output interfaces of all nodes that forward. And we don't have to put bits because the Bloom filter does that for us.
No, but I'm saying this is about, sorry, this is point 2. This was not about
Yeah.
Bloom filters anymore, right?
Yeah.
So I'm saying when I'm not compressing the bit string, I think I can reduce the bit string size by really only carrying the interfaces between routers, because when you don't have a bit, you can easily come up with a rule that says, oh, okay, so now my next connected hop is going to be looked up through looking up the unicast address in the IP header. Following,
Okay.
right?
I came up here just to talk about the use case. So the reason we developed this was the control problem. Think about lighting systems, where you want to talk to a few dozen light bulbs at the same point in time. And the actual payload we have there is very small. So we actually expect the payload plus the network overhead, including the Bloom filters, to fit into one 8215.4 packet, which is 128 bytes. And you have to remember that of those 128 bytes, you can use about 70 to 80 for actually useful things. So there's already some, you're paying a lot of tax already for other things. So spending like 32 bytes for a Bloom filter was for us the benchmark, whether we could make things work in that environment. So more than 32 bytes or 256 bits was kind of outside of the envelope.
I'm just trying to bring in, alternative approaches to deal with the bits. Now, obviously, if the control is exactly to control, a subset of end nodes, I would say end-to-end beer. And yes, every end node or interface to an end node would need to have a bit, but I'm saving all that space at the application layer of the payload, right? And if that's not what I'm wanting to do, then basically, for the unicast, for example, I can save bits and basically come up with 2 bit string sizes, one larger one, you have less payload for multicast, one short bit string size just for the intermediate one. Unicast, you have the shortest possible, network header. So those, and you can have them together, right? I mean, that's not an issue.
Yes, I think there's a lot we can do, in particular for unicast. There are 2 aspects that I really want to discuss here. For unicast, it's just a matter of you don't think that you have to place the bitmap in the packet. That's wrong. Virtually it's there, but now you think that everything we put in the packet is compressed. There is 6-layer edge or things like that. So what is the 6-layer edge for a unicast bitmap? Well, it's probably the minimum set of bits to express one integer of which is the one you want to represent. So even if you have 1,000 bits in your bitmap, if you're sending something to Mr. 13, you can express that in 4 bits.
So you're saying I'm deterministically, or what is the right word, loss-free compress the bit mask.
Right. And so the other thing is, if I'm using bits, then if I have 256 bits, all of a sudden I'm screwed if I want to have 257 nodes. Well, no, because when you send a bitmap, you can always say, I eliminate the header zeros. Right. So you can grow it by just dynamically. It's just, can I transport that in a compressed fashion? So the key thing here is how you express the compressed fashion. But you're not limited. You're not.
No, that's fine. But
mostly unicast, right? Unicast can be, actually you can see beer as a compression method, much better than 6LoWPAN for compressing the IP address.
It's just that, I think from the simple things, right? So this one, I know deterministically how many bits I need, right? On the far end is the Bloom filters, where I would like to see a lot more statistics. Now you're talking about loss-free compression of a bit string, that's somewhere in the middle, but also something where, for example, topologies, we would need to run the numbers, right? Obviously, the big benefit would be that if you do a small group multicast sent to 2 or 3 nodes, obviously, my idea would only work for unicast to compress it there, right? So
well, you can also express a list of 2, 3 integers in much more concise way than you can express 1,000 bits. I mean, for now we have to think architecture. The compression will come, and we know we'll have ways to do it.
But I think these high-level choices that we make, right? I think what we're trying to figure out, what is the minimum set that we can focus on, that gives us the best return for the investment, right? And the less we can come up with that, the more we need to be broader in what we're specifying and standardizing, and that's ultimately going to be more work than right.
Yeah, so the reason why the compression technique influences the architecture is that if you are compressing bits, then of course there are many ways of doing this. But if you're compressing lists of output interfaces, then you have to think about a different model. So that's just a different architecture.
What's the difference for you between, if every bit is just an output interface anyhow, what's the difference for you?
In IP, I have 128 bits to number output interfaces. That's a pretty long bit string.
It's 128 bits?
To number those output interfaces. So you are assuming some mapping from the output interfaces to a bit position. And we are not assuming that exists, so that simplifies some things. So you have to have a state management protocol to establish that mapping,
Right, right. Which actually I think is,
which is part of the architecture.
right, which actually is this slide, right? So I think the question is, to me, what's the method of signaling, right? And the way I understood it, there is a lot of history in Ripple and much of the signaling also being, end node driven, right? Going up to the root. And there's obviously signaling from the root as well. I would be saying that especially if we're doing the TE stuff, where we're basically trying to engineer something on the path, like, we have multiple alternative paths going downstream, and we need to figure out which particular traffic uses this path and the others, so could be arbitrarily complex trying to load share the traffic, right? If I'm already having that much centralization on the root with all the policies involved, it would certainly be very, inline if also the signaling for the assignment of the bits to the output interfaces was driven by the root, because then I can do cool things, for example, like make before break assignment of bits, like I want to renumber. Okay, I first assign new bits, but I'm not using them for the traffic. Once they're established, I'm basically starting to send with these bits. Now I remove the other bits, right? So it allows me to have very smooth, reliable mechanisms that are very hard to replicate if I'm trying to do distributed signaling stuff from the receiver nodes. So yeah, encapsulation compression. So I mean, you folks already have a lot better ideas on that. Why don't you bring them up on the design team mailing list, right? So the compression, right? What was I trying to say here? Yeah, so I don't understand the existing header compression schemes, right? But if I'm trying, for example, on the things that I do understand, to make, for example, these crazy, stupid, bad IP multicast applications work together with beer and compress it, right? Then I think I would assume that the number of multicast groups that I actually need is fairly small, right? I might only have a single group for a particular multicast group, like all these, light bulbs, and I still use the bit string, right? The loss-free compressed bit string to indicate for every individual packet what the receiver is. So the IP multicast is just a shim to the stupid receiver application that doesn't know beer, right? That's just receiving its multicast packets because of the multicast group. And the only guy I need to be able to set and deal with bits is the application integrated or near the root node, right? So that way I don't need to upgrade my receivers. They still have multicast, but I need a small number of multicast groups. And so I can extremely compress the destination multicast IP address of the packet. Maybe just down to 4 bits, I have, 16, multicast applications of the network, good forever, right? Just to show the most extreme case I can think of.
Yeah, in our use case, it wasn't entirely useless overhead because the controller was outside the Ripple domain. So
right, but I think we can come up with schemes so that the controller can send actual beer packets and not only multicast packets, right? So I think that would
yeah, but now you are kind of moving into, let's do an IPv7.
No, it's called beer. We already have a name. We don't need a crazy...
Right, but you suddenly have to touch a lot of nodes on the way to make that happen.
I can tunnel that, right? I mean, I just tunnel it from the application into the root node.
Right.
Very
Okay.
simple.
Yeah, except if you have an operating system. Yes.
No, I think please throw the concerns at me so that we can all address them in a proposal. So.
So what you're essentially saying is I need an application layer protocol to talk to my root node for it to effect a beer multicast.
Again, tell me the alternative. Tell me how you would best, without, improving with the end-to-end beer, and maybe the trick that the receiver doesn't even need to understand end-to-end beer. He thinks he's just doing multicast.
Yeah,
right?
I can live with that. That's an interesting architecture. So for instance, the root node could be a CoAP proxy.
What?
The root node could be a CoAP proxy.
Oh, yeah. Okay.
So my application would actually send a CoAP request to the root node, and the root node actually finds out what the beer bits are that are needed for forwarding this as a proxy.
Yes,
That
yes,
might work.
and we have basically, we all have, you know, at least I and a few other folks, I think, some lying around drafts we didn't bring into beer in terms of the API, how to do these things. So that's what we would need to pull up and probably, you know, not even resolve here, but in the beer working group. But I think what the beer working group definitely wants is somebody standing up and saying, we have the use case we wanted. And if that's what role is saying, then, you know, might require rechartering. I don't know, but I think beer would be fairly happy with it. Work on it.
Yeah, so I think I want to spend some time with Peter talking about how such a application layer solution would look like, for instance, in FAIR. And
You will be very welcome.
Okay, so right, so I think this obviously is the ongoing thing that we need to finalize writing down in terms of recommendations, right? So BRTE approach required for storing mode, true. I mean, that's my current understanding. Sorry, non-storing mode, right? So the bit for each of the outgoing interfaces. Do we have a solution to just do it with beer without the bits? I think we need it for the non-storing mode, right?
Yeah, for me, it's just two words for saying the same thing, right? I mean, beer, normal beer means storing mode, and BRT means non-storing mode. In my mind, they're just two words for the same thing.
Okay. Fine. No, but I think, you know, on one hand, we can try to simplify and, you know, streamline whatever terminology we want to have, but the more we stick to what beer has already established. So, for example, you called the word in the header for, you know, a particular set of bitstring, not a set, but a group, right? So that's different than it's called in the beer working group. So I think that's unnecessary. I like group better, but, you know, the beer working group has chosen a different word, so just the terminology. Okay, so then the storing mode, yeah, so there was a...
Toulouse, you have been done 30 minutes and
Okay.
you still got 4.
Yeah. Okay. Yeah, so basically
Yeah.
just the closing remark would really be that, so there are a lot of cool things we can do, but really if you folks know some example topologies, which may not even need to be real world, kind of this exactly, but kind of the largest, a good mid-size, a minimum, right, a few topologies with the constraints, then I think we can each try to map our preferred options into that and then express how better the appropriate beer solutions would be. So that gives, I think, a lot more opportunity for people who are not into the matter in the working group to review, you know, whether they would like the work or not, because they're just interested in the results and not how we bake the cake. It just needs to be tasty, right? So that's it. Thank you very much.
Can I just...
Very good. Yeah, you want to say something, Pascal?
Yeah, I just want to react on two things that Thomas has said. And
I also wanted to react, actually.
I fully agree on that. The first thing is the root initiated bitmap assignment. I think it makes a lot of sense that the root assigns the bits when we're using bits. And the way we do our protocols today is already done like that. Like if you want to have a short address, you need to go up there via the root or to, well, if you look at minimum security at 6 dash, it always works that way. You're getting a number of information from the root or from some servers which is connected to the root and use that in the network. So it's just using the same flow. We need that, like we go to an LBR, 6LBR to do that and all those things. So it's completely consistent. Assigning bits is just yet another task that we'll have to do in there. The other thing, because Doris asked, is how we do REPL compression. There's only one RFC for that. It's 8138, and it's made for waiting for beer. Actually, we started a draft, which is the beer side of it, but it's very minimum. I mean, that draft will be damn interesting. It will be a lot of fun. So people think about it. Just what we said about the bit version, and then there will be the bloom. The bloom cannot be compressed, right? You have to know what your bloom size is. It's computed, it's pre-computed based on the world you know. There are optimizations. It works better, it can be optimized. Now, if your network changes from what it's optimized for, it's going to work. A bit less well, it's going to work. The bits version will have a lot more of the kind of fun you're very good at, which is, depending on what you want to do, unicast, multicast, how many bits I'm using at this moment of time, how can I express so that I just push the minimum number of bits in my packet to express exactly what I want to do. So there will be various, I guess there will be different ways of saying the same thing, and you'll have packet per packet to figure out which is the optimal one if you want to. So we'll have a very creative draft here. So fun in front of us.
Thank you for the word creative. I was very happy with Tourless that he could take the lead and that he has made this group. But unfortunately, I mean, there's been lots of momentum since IETF 101, which I really appreciated. I think it's a nice subject. There are lots of things to be done. And there has been this silence, and I really hope that we take up this momentum and can work on this subject. Did anyone who is interested not receive this group.com alias, the email address? If you didn't receive it, please complain to me, to Tourless, make sure that you're on it and can collaborate. Okay? Thank you very much, Tourless. Then the next one. Raoul. I think you go the wrong way. Yeah, that's the beginning.
Oh, I'm going back.
You want to go forward? Doesn't work?
All right. Holding it up. Okay, so a quick update here. There has been no major changes to the draft here. Thank you, Georgios, for the review comments, and we'll be making some text amendment to accommodate those comments. We have added Pascal as a co-author. Thank you, Pascal, for your inputs. Just briefly about the solution, what we are trying to do here is to optimize the route invalidation procedure. What happens is that the target node informs or make sure that the common ancestor node is in charge of the route invalidation procedure on behalf of the target node. So it's a fairly straightforward solution, but it optimizes. We have shown the numbers in IETF 101. We have a Contig implementation, and the numbers look really, really great. Not only in terms of route invalidation efficiency, but also in terms of reducing the control overhead. So the updates primarily were on the security aspects. We have included the DECO and DECO ACK, secure version of DECO and DECO ACK. We have piloted this implementation 2 years before, and it has been in the pilot phase since then. The Contig implementation is already open, and the performance report is available. Any questions? Happy to take any questions. Thank you, chairs, for calling for the last call already.
No questions? The working group last call has been started 2 weeks ago.
Sorry? Yeah.
So it's finished. You got one response as far as I remember.
Yeah, so we've got a response from Georgios. He has reviewed the document, and he has given the review comments. We will be updating the text to accommodate the comments.
I'm looking forward to more reviews actually of this. They have been discussed quite a lot, I must say. We have had many optimizations done and adjustments, but nevertheless having another review of the latest document will be very much appreciated. Yes.
Pascal, yeah, actually, we have a number of working groups who just started last calls 2 weeks ago, and there was the IETF preparation now. So it's actually very hard to do. I realized, it's hard to do this review 2 weeks before the IETF. It's a very dense period. It would be nice that we have a little bit more time.
I understand that there will be a Shepherd review as well, but I still think that we should need another review from the room here.
Oh, yes, we do. And
Okay.
so we can't close the working group last call. We need to give it more time. That's why I'm asking.
Okay. Any volunteers, or do I have to write to volunteers? Okay, thank you very much. Your name? Remy, okay, very good.
Thank you. That's all from my side.
Okay, very good, thank you very much.
Good morning. I'm Charlie Perkins. I'm here to talk about AODV Ripple. And by the way, it's nice to have the monitor there. So
Yeah, great, huh? Yeah.
we're getting into
Put your
the new
glasses
millennium
on.
here. Okay, so maybe just a little bit of background. AODV Ripple was in last call for this year, and the comments came back that there were a number of features in RFC 6997 that were not brought forward into AODV Ripple. And so that turned out to be a good bit of work. And then Remy observed that there was a error condition that couldn't be handled when we were really using the T-bit to try to save the space required for the target option by using reference to the Ripple instance. So I tried for a long time to try to figure out how to save that because it's a nice bit of optimization, but in the general case, it's extremely unlikely this would happen, but it can happen. And as far as I know, that any remedy would be worse than just taking the option out. So there's been a good bit of going around and on the design team, and we finally came up with this version 4, which I'll describe to you now, and which I hope will enable it to finish going through last call. Do that. All right. So I mentioned the T-bit, and I guess I should at least also to say that AODV Ripple is a peer-to-peer mechanism that handles, it can find routes to and from a destination that may not be symmetric. So that's part of the value of this document. So the T-bit was put in so that we wouldn't have to carry the address of the target if it was already able to be inferred from the instance ID. But it turns out that that's has a failure mode, and basically, if it turns out if let's see here, if both A and B in this picture, I have a pointer here too, don't I? There you go. So if both A and B are making a request for target C, and this route reply from C arrives at B, B can't tell whether or not that's from A's route request or from its own route request. So this is actually, and this actually can show up in, you might say, multiple sort of configurations. So it still may be possible at a future date to find a way to still not require the carrying of this target address. But in the meantime, since we want to go forward, we had to take the bit out. Then there was something that needed to be done. Since one of the features of the previous experimental draft was to have multiple targets, and well, it turns out we can do this quite in a straightforward way also with AODV Ripple, but it has to be careful. You have to be careful about how you forward the route request. So if you go through here, let's say A is wanting to find routes to destinations B, D, and F, and this graph shows the way that the route request is broadcast through the network. So when B gets that route request, well, it can obviously satisfy that with a route reply, but it needs to continue to look for destinations D and F, and so it has to take out its own address from that list. And then finally, the same thing goes on the other side, so that when D can satisfy the route request by sending a route reply, it retransmits the route request with the two remaining destinations B and F. And finally, E essentially takes the intersection of these and forwards the route request down so that F can send a route reply. So this required a bit of specification in the document, and that has also been done. And the final thing to discuss here had to do, oh, wait a minute, I also should explain how we manage this process of pairing the Ripple instance IDs between the route request and route reply. Well, there's still the case that you can have two different sources of route requests using the same instance ID, because these are local numbers and they don't do any coordination to maintain uniqueness. So when the target node C gets the route request and it wants to use its route reply instance ID, it should be the way the draft is written is that the pairing takes place by using a relationship between the Ripple instance ID from the originating node, but that could lead to duplication. So we allow now for that to, we should resolve that by this shift parameter. So if you look in the route reply packet, you'll see that there's a little shift that can be sent to make the local instance IDs still unique and allow the originating node to find out how to make the pairing. And then finally, about multicast, I didn't understand exactly how the multicast was supposed to work in 6997, because when I tried to map it out, it looked like it would be terribly, terribly inefficient and cause a lot of overhead traffic in the network. So for that reason, and also because there's this other work going on with other approaches, I think that multicast deserves to be a separate effort anyway, and hopefully we can go forward with AODV Ripple without providing a multicast solution in this specification. Just as an aside, there's been sort of related multicast efforts going on in other groups in the past, and they ended up basically finding it's a pretty complicated problem as well. So I guess that's the end of the presentation. Certainly would appreciate more review from the existing document, but we've gone over it pretty well with a fine-tooth comb, and so I think it's quite ready to go forward.
Pascal, many thanks, Charlie. This goes in the right direction very well. I'm still a bit confused with the pairing of Ripple instances.
Mm-hmm.
So we're using local instances, right? So
Right.
The number itself is meaningless. What's meaningful is the pair IPv6 address of the root, comma, local instance for that root, right? That's the tuple which now gives you a unique, network unique thing. And now what we're doing is we are coupling one from the left to the right to one from the right to the left, right? So there are really two numbers, two tuples, address / local number, right?
Mm-hmm.
At the end of the day. And so usually when you do that, like you have a USAP and a PSAP or whatever you call that, it's just a matter of sending back to the other, oh, when you talk to me with this USAP, I talk to you with this PSAP, right? Or something like that. So why do we have to have all those shifts? Can't we just say, okay, your name for our relationship is your address, your local instance ID. My name for the same relationship is my address, my instance ID. Let's just pair them, and that's it, right? That's, I mean, what everybody does.
So you're suggesting that we don't maintain this concept of paired trees?
Well,
Or
the two pairs must be, I must know that your name for our relationship is your IP address, your local instance, and my name for that same relationship. So they are linked. It's just that having a shift or something, they're just two numbers picked from two different spaces. The space is the IP address of the root, and then you get this number within that space. We just exchange as part of building this. The route request, you give me your name. In the route response, I say your name, my name.
Well,
I'm just confused that it's not just as simple as that.
I don't actually have a good answer. Remy, do you want to address that?
Remy from Huawei. In fact, there's no problem from the original. The problem is at the tag node, okay? Because
Right.
there may be two original which requires the route to the tag node at the same time. Yeah, yes, of course, that one is unique, yes.
So we want to have the target node when it responds to supply, its instance ID that's paired with the originating node thing, but it can't do that in all cases without this sort of being able to shift it just a little bit.
Oh, basically, you say, you send me a route request, Charlie, 5. I say, okay, I will send a route reply, Pascal, 100. And in the reply, I put Charlie 5, Pascal 100. Pair. And now you store Pascal 100 and I keep Charlie 5. Each time I talk Charlie 5. It's like it's a new talk, you talk Pascal 10, whatever number I picked. That's the user SAP, provider SAP, service access points. Remy from Huawei. In fact, the problem is that the tag node cannot merge these two requests using the same repo instance ID, because you may have different requirements from the two original. It is not the same DODEC. It's two different DODEC, but in the route reply, I should have a small option somewhere to just say, hey, this route reply is the reply to the route request, which was sent from Charlie 5.
So that's effectively what we do. I mean, we don't add very much overhead to make this pairing, and it seems to work for exactly that sort of correspondence you're talking about.
I guess it doesn't just concern with this shift. I should be able to pick Pascal whatever number I want, and just tell you it's Pascal 10, right? And why do we have to do shiftings and stuff? That's what got me confused.
So,
Well, that is another question, because between the same pair of original and tag node, we can have multiple instances. Yeah, and from we're using the same instance ID for the pairing to indicate that, because the REQ and the RIEP instance, they share, these two .ID, they share the same instance ID. Sorry, it's because for pairing between the same pair of original and tag node, it may have the multiple instance, right? Because, for example, multiple pairs of instance, yes, and it may be at the same time. So if we want to pair the two instances, we can somehow to do the pairing. Currently in the draft, we use the same instance ID. Why?
maybe this is something that could be
No,
fixed with
it's
two or
not
three.
duplication, because the DODEC ID is different. One is the address of the original, and the one is the address of the tag node. So there's no duplication in this case. Okay.
I think we can do this in 4 or 5 email messages. Yeah, all right.
Rahul Jadhav, Huawei. So the pairing of DODEC ID is sort of a central to this draft, is what I thought always, when I reviewed the draft. And one of the reasons why it might be required is because on the intermediate hops, they have to keep a mapping between what was the route request and the route reply, the instance ID. They have to make sure that the route reply is on the same or on an instance ID which matches to the route request. So that is why the pairing is required. Pairing is sort of central concept for this particular draft, in my opinion. Yeah. So now there, like you mentioned, we can have a completely different instance ID, which is managed by it. So then we'll have to have additional bits in the reply, which says that, okay, the original instance ID was this. So it requires more, I feel that's where it optimizes. So in fact,
We don't actually introduce very much overhead for this pairing. That's the point. It's about as minimal as you can get already. It's just we had to take care of this case where there's conflict on the local instance IDs from the target node.
So one more thing. So I reviewed the latest draft. As I understand that the odd even pairing is completely gone, right? The pairing of instance ID based on odd even. So the route request is an odd instance ID and the the route reply is an even instance ID.
Oh, no,
just the
we
bit
don't do
flipping.
that anymore.
That is no more there, right?
Right.
Okay, that sounds good actually. In fact, I've seen the shifting of instance ID concept. I feel it is the best way of solving the issue. It is really nice way of making sure that the target node doesn't end up with the same instance ID from multiple this thing. I didn't get it in the first place. So what? Okay, all right, yeah, thank you.
So, yeah, that even odd pairing was like a 1-bit mechanism. Now we're all the way up to 6 bits or something.
Yes, right.
But, right, it's pretty economical and it works. And if there's a ambiguity, maybe we can work it out on the mailing list or something.
One more final comment. So people keep saying me that this is highly improbable to happen, that it is not possible for the instance ID to collide, and I really don't feel so. The entropy is just 7 bits. It is going to collide for sure. So this has to be handled clearly in a very good way.
Right.
6 bit, no, now it is 7 bits because that 1 bit is now, no, yes. No, 1 bit is now removed, went back, right? The earlier the odd even bit, local or global, and then the 7 bits. Oh, all right, okay. Yeah, it will definitely collide. Yes.
Okay,
That's it. Thank you very much.
not completely. Who has read the last version of this draft, please? Who has read the last version of this draft? Ah, you did. You wrote it as well. Okay. I should like to have some reviews of this draft. We were in working group last call 2 weeks ago. We was very little information. There's still plenty of room for discussion here. We nevertheless want to conclude this draft, so I'm looking forward to reviews. One. Very good. Okay, I'm looking forward. Is there a second volunteer, please? I will feel much better when there's a second volunteer. Yeah, you'll find somebody. Okay, Pascal, thank you very much. Then it's up to you. Yeah.
So is it going to the there? This is talking to the,
It's talking to this one.
okay, but if you're using the Chrome thing, do you have one?
It works. It has worked. You look.
Oh, I understand it works. This is connected to your PC and
Yeah.
this is connected to a screen. right?
Yes, it does.
Now, if I was using the Chrome thing, would I have that or do I need to press the button?
You don't need to press a button for the moment.
But for the moment, I'm just asking for later. So,
Not that I know.
Root initiated routing state in REPL, DAO projections. There was some discussion on the mailing list about the complexity of implementation thanks to Raul implementing and feeding us back. So that's really great, and thanks so much, Raul, for that. And so we did a number of things. The first thing is inviting Raul to the draft, because he did a lot of work on it and discussions. And he also pointed out that we've got to better discuss the loop avoidance problem. So we'll probably in the future work harder even, but there's already things started there. Then there was a discussion, and Michael Richardson, who's not with us today, had a point about whether this protocol should also be the way the root knows about the capabilities of the devices. Because one key point in this design is that the root pushes state in the devices within what the device can take. So it needs to know what the device can take. And for us, this was control plane. Like, how do you know the topology? How do you know many things else? We know we need this component somewhere in role, which will feed the root with here are the peers, here are the neighbors, here are the cost of the link, whatever metrics you use, etc., etc. So the root can make intelligent decisions, right? I mean, just like any traffic engineering protocols, we will need a REPL TE of some form to feed the root with intelligence about what's going on in the network. And I thought that the capability of the node would be part of that intelligence of the network. Now, Michael's on a mail he sent like a year ago pointed out that we should provide us information within the protocol. So, I need feedback on that. Nobody on the mic?
Rahul Jadhav from Huawei. So you're saying whether Ripple itself should be made use of to provide this feedback?
Yes, what we know we need this feedback.
Yes.
Should it be this specification or a specification which is missing anyway about all the more topological information for the root to compute all this, right? Should that be all one single big document or should it be two documents?
The feeling that I have is, ideally this work should have been done as part of meshing establishment draft. Unfortunately, it has been expired in 6-law working group, but that would have been the best way to actually send this information to the root.
So you agree that it's a different draft?
Different draft, yes, definitely.
Anybody else? So for me, this draft is all about the machinery to establish routes. How the root knows which routes to establish is out of scope. So Rahul seems to agree, which tells us that we need this other document which informs the root first about what's available on the network, including the node capabilities. Okay, so we can confirm that at the mailing list, but that seems to be, that's consistent with what the document does. Another feedback we got, and from Rahul again, was that, and I never liked it in the previous version, how do you know if you're using a storing mode or a non-storing mode? RPO, as we call it now, route projection option. And so the resolution on the mailing list was to actually make two of them. Have a different option if you're using source route versus non-source route via option. So nobody contradicted that on the mailing list, so we edited the documents with the change. Now you have, we call the generic route projection option RPO, but then there are two different codes. One of them is the source route via option, and the other one is the normal storing mode via option. Now, looking at loop avoidance, there is a bit of a complexity here. The question is, can we trust that the root will never make a mistake and that the state is always installed correctly everywhere and stays there all the time? If that is true, then we don't have a loop. But it's very clear that we can trust that. At the complete extreme, can a node which forwards along the projected route make sure that is going to get there without a loop? And the answer is, yes, there are cases where you can make sure. An example of that is a strict source route. If you have a strict source route, you know exactly the hops, so either the packet gets there or gets dropped, but it will never loop, because you have the strict source route. If you have a loose source route, now you may have a loop, because getting from one hop to the next hop over the loose source route may actually take you behind yourself. So, now I start having problems. So basically what the text says is that when you're getting a new route, whether it's storing or non-storing, you must be loopless to get to the next hop. That's what the text said today. That's a new text. And the text says you must know that you're loopless to get to the next hop in the whole route. And to be loopless, either the guy is a direct neighbor of yours, or you have a strict source routing path to him. Or recursively, once you've done all your route recursion, you have a strict source routing path to the next hop of your recursion. And this way, you know that you will get to the next indicated hop without a loop. So if the global route end-to-end is loopless, and you know that you have no loop between each hop, then you're okay. So basically, the text today says, do this check. Okay, so you can have it's complex, right? You can have a multi-hop source routed path, which is loose, but to get to the first hop, you must have a strict. Or if it's a loose, then to get to the first hop or the second loose, you must have a straight. Or the guy is your neighbor. You see? So that's what the text says today. And if people are interested in thinking about that and coming back, but that's the rule that we have right now in the text. Now, we still have this discussion on how and whether to use the obit, or an equivalent to the obit. The obit says you go up, you go down, but you can never go up again. It's pretty much what it does. With projection, you can do whatever you like. So you can't protect against that. The one thing you can protect against is if you enter a projected route, you should never get out of the projected route. Because you're deeper into a nesting of topologies. And if the loops that you get in multi-topology routing is like, I live in this topology, I move to a lower topology, and that can be loopless. But if I come back to a previous topology, now I can have a loop. It's a bit conceptual, but as long as the routing topologies form a directed acyclic graph, you're loopless. That's pretty much what this says. So going from normal ripple routing down to a projected route is loopless, as long as you never go back to a normal ripple routed route. So there's a possibility to use an equivalent to the obit, but it's not up and then down and then never up again. It's normal ripple routing, then route projection, then never ripple routing again. Okay, so that's pretty much the complexity. I mean, the rules can be very simple in the final spec, but understanding exactly what we are doing here requires some brain work. And finally, we never discussed on the mailing list the mode of operation, but there's still this question of how do we signal which mode of operation, do we need to define new mode of operation, etc. There are only 3 bits, it's already saturated. So what do we do here? That's a more global ripple plan. So yes, that was pretty much the discussions I wanted to have with the group on the mailing list. We kind of said for the first 2, these both go in a separate document that we need to write. Mixed mode is, for instance, I have a storing mode projected route to somebody, but it's loose and I can use non-storing source routed to my next hop. Do we want to support that? Right now the draft allows it, but do we want any sort of mix, like the ripple around us is non-storing and we are using storing mode projection, and inside the storing mode projection we are using non-storing reachability to the next hop? Well, I mean, it works. Do we want to support all this? Question to the group. And that's pretty much it. So basically, I would like people interested in thinking in deep thought, basically, of exactly how far we want to go with those things. Because Ripple, when we did it, the decision was to keep it very, very simple, like don't mix mode at all. Right? When we did route projection, it made a lot of sense to use a projection mode which was not necessarily the same as the ripple around it. For instance, you use non-storing, your source route, but you project storing so you can compress the source route for long lines. That makes a lot of sense that the projected route is not necessarily the same as the ripple around it. Now, do we have use cases where we want to mix storing and non-storing projected routes, for instance? That makes sense. It's doable. Do we want to support it? It's just a matter of complexity of the code. Maybe feedback from implementations again.
Hello, I'm Rahul Jadhav, Huawei Technologies. So this, the hybrid mode of operation is definitely required because non-storing mode of operation has its own limitations. Storing mode of operation has its own big limitations. So we need an hybrid approach. We plan to use it in our implementation as well.
Even in the projection world, so you will have projected storing and non-storing routes in the same network.
Yes, that is what the draft says currently, right?
Yeah, that's what it
Yes,
does. Yeah, I
yes.
just want to make sure because it's more complexity. And I remember at the time we did Ripple, some people reacted to this sort of complexity and say, let's just make two different networks. And that's why we have storing and non-storing and no mix of them, right? I mean, it was an oversimplification, if you like, but we took this path. I mean, my early implementation of what became Ripple could do both at the same time, and I had no problem doing it. But the working group said, let's make that separate. Okay, but right, I mean, if your implementation, if it doesn't hurt you to implement what the draft says, I mean, that's a feedback, right? The best feedback possible. It's implementable. Let's do it. And well, don't sit.
Let's conclude. Okay,
It's done. It's done.
yeah. Thank you.
Okay. Hello, everyone. Rahul Jadhav from Huawei Technologies. So this draft talks about some of the observations that we had when we tried to deploy the storing mode of operation. Now, what we want to do is we want to bring to the notice of this working group what are the issues with storing mode of operation and that people have to choose it wisely. This is one of the possible outcome. The second possible outcome of this work is that we might have some errata added to 6550, or we might, this work might result in new working group drafts, which might try to solve some of the issues with the storing mode of operation. So most of the observations that were done here were when we were trying to deploy the smart meter or the AMI smart grid network in the last mile with 802.15.4 in the single channel mode of operation. We had some sort of implementation in place for the problems that were described here, but we definitely feel that whatever the implementation or whatever solutions we had worked on are definitely not the best or not optimal. So one of the discussions that we had before going into the details of the draft, one of the discussions that we had on the mailing list was regarding whether DTSN is a lollipop counter or not. Well, 6550 says no, and this is something that we realized later when Michael pointed out. DTSN stands for Dow Triggered Sequence Number, but having said that, it is not supposed to be a sequence counter because there's an explicit section in the 6550 which says sequence counters, and DTSN is not mentioned there. So one point is clear that the implementations are clearly confused right now. So in our internal implementation, we have thought of it as a lollipop counter. Contiki has also thought of it as a lollipop counter, but Riot has not thought of it as a lollipop counter. So there is definitely a confusion about that. The bigger question is what it should really be. Should it really be a lollipop counter or no? Now, one of the issue with being a lollipop counter is that you have to start randomly with the new DTSN when the node reboots. And if it so happens that when the node reboots, it picked up the same DTSN on which it had stopped before the reboot, then the outcome is unpredictable. When I say unpredictable, it means that the new node might not be able to join in the network for a longer time. And how long, that is not really known. Yeah, Pascal?
Pascal, your picture is wrong. I mean, the round part stops at 128. It's just,
Sorry?
the circular part stops at 128. It's just a slight error on the
Yeah. So this lollipop diagram is slightly wrong. Yeah, where 1 to 127 it should loop and then go back to 1. Yeah, this is something I realized later, but I didn't bother to change the draft. Thank you, Pascal, for pointing this out. Yes. So the circular part only deals with the positive sequence. So here it is clearly gone into the negative sequence as well. But then, so what I was trying to say is, if DTSN is not supposed to be a lollipop counter, then if it is simply a random number chosen on the node restart, then it has its own problem. In that case, you have to actually flash every update to the DTSN in the persistent storage. If DTSN is considered to be a lollipop counter, then it makes the life more easier, in which case the linear part is the only part which goes into the flash. And once the node goes into the positive part, then you don't need to flash it again. So it's actually better, in my opinion, to actually have DTSN as a lollipop counter than not. This is something that I feel this working group has to consider. If it is considered, then it might require clarifications in 6550. Regardless, it requires clarification in 6550 because implementations are taking different routes already.
Pascal, I think that if we start making this sort of discussion, we should start an RFC 6550 update.
So,
If we start having this sort of discussion, which is very, very, very interesting, we should open a draft RFC 6550 update. Because we need to
I don't
store.
know what it means.
Oh, it's just a
sorry,
new
did you-
draft, which is the update of REPL.
Oh, okay, all right, okay.
It's start to think about, okay, let's fix the bugs, right? And that's usually called an update.
Okay.
So why don't we, I mean, chairs, bill of interest here. Why don't we start thinking about creating this draft RFC 6550 update thing? You know, we talked long ago about trying to make an internet standard of REPL. At the time, we were missing feedback and this sort of work that Raoul is doing now. And I guess the result of Raoul's work could be that now we have a better quality update document.
I think this has been mentioned a few times before, but yeah, we might start thinking, but not no decision today, please.
Okay, so one of the other things that hampers storing mode of operation is the use of DTSN. So DTSN is clearly the biggest, has the single most biggest impact on the overall operation quality of REPL in storing mode of operation. So this, it has dependence on the route update for the dependent nodes. It has implications on the downstream node route availability. It has direct implications on the overall control traffic overhead. And there are, it's very difficult for an implementation to judge when to, for example, increment the DTSN in the first place. Should DTSN be incremented with every diatrical timer? Well, it definitely sounds like a very bad idea, because then you'll have a sequence of DAOs flowing from the node upwards, because with every incremented DAO, DTSN, the end nodes are going to send their own DAOs. So that sounds like a very bad idea, but then the problem is that the DAO redundancy in case of storing mode of operation will become very less if the DTSN is not incremented in case of every diatrical timer. I know previous versions of the Contiki implementation used to increment the DTSN every diatrical timer, but then it stopped doing that because I'm assuming it would result in high control overhead. But then now the Contiki implementation has a smart implementation of the way DAO ACK is handled. So I'll talk to it about in the later slide. So this is another big problem that I feel has a direct implication on the storing mode of operation. So another question that we always faced was on parent switch, should the node increment its DTSN so that all the neighboring peers realize that there has been a change in the parent, so that they have to update the DAO DTSN so that an updated DAO can be flown. It's not only about the neighboring peers, though. The complete DAG rooted at that particular 6LR needs to be updated. The whole route, the sub-DAG has to update. There is a specific text in 6550 regarding this, that when the parent switch happens, the sub-DAG rooted at that particular 6LR has to update the route. But how to do it, whether it should be done by incrementing the DTSN, that is not mentioned. How that sub-DAG route update happens is not clearly mentioned, or it is actually very difficult to clearly mention that in the 6550.
Yes, and there is a reason for that, because it really depends on the reasons why you reparent. If you're a mobile node and you reparent because you moved, probably your children, you know, depending on the use case, but they moved with you or they did not.
Yeah.
And so you have to expect what kind of use case you're in if you have a good chance that your children did not move with you, then you need to send DTSN to see who's still there. Because normally if you move, you have your routing table. You don't need your children to rebuild the DAO for what you have in memory. We had this discussion last time. You're supposed to be able to recreate DAO for everything in your routing table. So when you move, you can always tell your parent, I've got all those children, but do you know for sure? Because you moved. So maybe they did not, maybe they did, maybe they did not. And if you're in a smart grid type of environment where everything is very stable, there's a good chance that your children are still there. So you could say, okay, let me advertise that I still have them and send all my children to my new parent. But if I'm in cars, something much more mobile,
before I advertise anything on behalf of somebody, I should make sure they are there. So I should not advertise them. I should update the TSN, and whatever I'm getting from below, I send above.
Correct. So that is definitely another way to do it, so that the 6LR itself advertises on behalf of all the subchannels to the upstream peers. That is another way to do it, but that requires target aggregation. Multiple targets in the same DAO, and that is very inefficient. So for example, if I have a routing table size which is 50 or 20 or 50, even modestly sized routing table, it's very difficult to send aggregated targets. And 6550 doesn't mandate reception of aggregated targets in the DAO. Doesn't mandate. So there are some open loops, that open holes in 6550 that we are trying to point out here. Another point that I'm going to discuss about is the DAO Act. Now, there has been a discussion on the mailing list. So there are multiple interpretations possible already, and we can see these interpretations happening in the current implementations already. So there is hop by hop act acknowledgements. You send an act to its immediate peer, and the immediate peer responds back as it is. So there are the advantages that the sequence of operation is really, really straightforward, very easy to do. There is no additional RAM requirement. There's no additional state that is to be required. But the biggest problem with the DAO Act in storing mode of operation is that how does the target come to know that the DAO indeed has reached the border router or the root? That is the biggest question that has to be answered by a DAO Act. In case of non-storing mode of operation, it is very easy to determine that because the DAO is directly targeted to the root. But in case of non-storing mode of operation, it has high level of complexity, and that is what this is. So the recent Quantic implementation tries to do something like end-to-end acknowledgement. So the node sends a DAO upstream and doesn't act it immediately, unless until the border router starts responding with the act. So that is one interpretation that has been done based on 6550.
I'm confused that you can understand the spec that way, but I can promise that's not the intent. The intent is you acknowledge, you get something, you just acknowledge it. It's just a layer 3 acknowledgement when you don't have a layer 2 acknowledgement, but plus it goes a little bit higher in the stack. So it acknowledges that the Ripple router above you has understood your DAO. We discussed that last time, but the intention is clearly you acknowledge immediately, like on the left.
Right.
And what makes it so that it reaches the top is that if your parent cannot advertise that up, then it needs to reparent until he finds a way to advertise up. But if that doesn't work, then he needs to poison. So you know, and now you go somewhere else.
Right.
So this is working. It might not be spelled well. That's what the update document can be useful. But this is working. It may take time if one of your parents is completely broken and it does not poison yet. And that's actually a way for him to discover is there that he needs to poison. Yeah. But if you have a chain of parents, each time you send a DAO hack, you take responsibility of progressing that DAO up.
Yes.
One way or another, or poisoning if you could not.
So this essentially is the third interpretation that I'm talking about. So this is, thank you, Pascal, for having this discussion in IETF 101. But there are certain issues with that interpretation as well. For example, let's consider node N3 here. If it has to keep state on behalf of the complete multiple nodes in the subdo DAG, so that it can retransmit DAO on behalf of all those nodes, retransmit DAOs. So that state is substantial first. Second, it still doesn't guarantee to know, because the node has already replied with a DAO act to the downstream neighbor. So if for some reason it might still fail, let's say, for example, the node got stopped. The node N3 got stopped. There was an alternate path available from here. For some, no, it got stopped, for example, it moved into out of coverage. It is not possible to poison, let's say, for example. The node got stopped or it got moved out of the network altogether. It's not possible to poison the nodes. So, yes. No, there is no timeout here because node N4 has already received a DAO act from the upstream.
You need to keep track of your parents, right? So if N3 just flies away like Superman, N3 and N4 will reparent.
They will reparent, but they have already received DAO act for the DAO that they have already sent to N3. N3,
yes,
while
but when you reparent, you need to send a DAO for your whole list.
Yes.
Or do the DTS endgame, but so There's no hole.
So if N4 sends a DAO to N3, N3 sends a DAO ACK back,
Yeah.
and after that N3 goes off.
Yes, so
There is no way N4 knows.
N4 keeps monitoring N3 because it's its parent. So if it times out N3, it reparents and now sends all those DAOs. That will be a temporary black hole. But N4 is in charge of reparenting and sending the DAOs either directly because he has his list or through DTS endgame.
I feel that's still more information, that's still more state. The state has been retained for a still more longer amount of time than what it was required currently. I mean, in this case, N4 will have to keep checking whether N3 has got out of its range. I mean, if reparenting is not an easy decision. Now, N4 is not sending anything actively to N3. If N3 moves off, there is no way N4 will come to know. It might happen.
You have to monitor it one way or another. Either you monitor your layer 2 activity, you monitor his DIOs. You can't stay for 100 years having lost your parent and you don't know.
Okay.
So yes, you have to monitor your parent one way or another. There is text in repo which tells you that.
Okay.
And repo has ways, if you don't have a lower layer way of doing it, just like NUD, right? If you don't have a lower layer, then you just send a disk or whatever you like, but you need to monitor your parent.
Okay, just one more problem that I need to highlight here because the context is right here. So what happens if N3, it tries to send the DAO ACK above, it receives a negative acknowledgement on behalf of N4. What does it do then? Let's say, for example, N3 tried to retransmit the DAO. It sent a DAO upstream.
Okay.
That cannot be handled.
So that's one thing that the report designers rejected to consider. We decided that if you use storing mode, you need to have enough resources so you don't have to negative. So you always have an alternate parent which won't negative, basically. So if you fail with N1, then you go to N2. But if basically what designers said was like, if you don't have a parent with enough storage for your DAO, then you have a network design problem, not a protocol problem.
Okay.
That's you know. So the whole game of beer, for instance, is to avoid that case more. And in the meantime, people said, "Oh, if that's so, then I won't do story mode." You know,
Exactly. Yeah. That is why people are running away from storing mode, in my opinion. Yeah.
Yeah, Simon Duquesnoy. So Pascal, from what you just said, I think you might have just answered what I'm going to ask, but just to clarify. You're saying that if you don't have end-to-end DAO ACK, then when you take a DAO, you acknowledge immediately and then you're committing to forward. And then if you fail, you poison. But do you poison unicast to the specific child or do you broadcast poisons?
Okay, so two failures, right? The one that we don't support is I give to my parents now what I got from my child, and my parents returns negative because it doesn't have storage. We said, okay, out of scope.
Okay, out of scope.
Okay, design your network so you have enough room in the parents. That's basically what Triple says. I'm not saying it's
Meaning
perfect.
every node must have enough room for the whole network.
That's pretty much the design. Yeah, that's why people don't do it. And well, we do it in a smart grid. So we have bigger nodes. I mean, you have nodes which are big enough to store your network. If it's because it cannot send to the parents, it never gets an acknowledgement back. That's when he discovers that the parent is gone, then you poison all the way down, and so you see that.
Yeah, that makes sense. But then I would say maybe it's just a good idea to clarify in the text,
That's
right?
what we talk about.
That we have that assumption that every node must have enough space for every.
Oh, yes, that's written somewhere.
Okay.
But basically, Raoul asks all those good questions. I mean, the text, basically what Raoul points out is gaps in the explanation in the draft. After that, you can say, oh, I don't want to, I want to support storing mode, and I can't agree with this limitation out of scope, right? That's new work. But at least the existing work should be self-consistent, self-explanatory, and clear. And what Raoul shows us, it's not necessarily all that good. So without changing anything in the spec, at least clarify what it's supposed to do is a very good first step.
Yeah, but I have a slight contradiction to make there, sorry to say, but whatever the three interpretations that I have pointed out right now, which are the possible interpretations as per RFC 6550 right now, I don't feel that they solve the right issue. I mean, still it is possible to actually have a much better implementation of DAO Act in storing mode of operation, with much less overhead, both in terms of control as well as the resource. Yes. 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 That's a new work, definitely. So, but that is what I feel. It's very easy to implement. It's very resource friendly. The biggest problem with that mode is ACK aggregation on the written path, but I feel that might not be a very big issue, because right now it is possible to aggregate multiple acknowledgements, the DAO acknowledgements. It is possible, but with this unicast directly to the RU, with the DAO ACK getting directly to the target, it's not possible to aggregate multiple ACKs in the same packet.
Raoul,
Yes.
yes.
Right. Yes. Yes.
I
Yes.
ask you to conclude
Okay. All right. I'll move on fast. So I've already talked about multiple aggregated targets.
and
So
conclude
there's-
fast.
Okay. 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 So this is what I already talked about. The DAO retransmission and DAO ACK. It is possible to solve this problem in a much different way. But then again, this has to be discussed on the mailing list. Handling node reboots. I feel this section can be removed, because I feel there is an implication on flash handling as per the draft that is observed, but you can't really do away with it, in my opinion. So lollipop counter is the best way of managing the state information. You have to still flash it. Again, there is some work that is required for handling resource availability. Some work has been already driven by some of the drafts. For example, in 60s, there is the rank priority and joint priority that sort of solves this issue. This basically, the issue is what happens if the routing table gets full on the upstream node, what happens if the neighbor table gets full in the upstream node. Some important points, miscellaneous points: should transit information be optional? Right now, the RFC says it is optional, but clearly it cannot be made optional because there is lifetime, and I think there is other work that also requires it to be mandatory. Aggregated target containers. Can aggregation be made optional? At least can 655.0 says that at least the reception should be mandatorily done, if not sending. The reception of aggregated target containers should be mandatorily done. Okay, so I had some thoughts on how this should be done, but I think this will have to take it on the mailing list, I guess. That's all from my side. Thank you.
Yes, thank you. This has been asked to be adopted by the working group. There has been some reactions have been. Who has read this version of the draft? 1, 2. Let me ask you to read this draft and put on your comments on the mailing list and see if you really think this should be adopted by the working group.
It's a very important document. Don't take me wrong, but I don't see the purpose of adopting it. It can have two different outcomes, which are both important. One of them is an RFC 6550 update, digging from there to know what to do and what the problems are to be clarified. Very great work, very useful. And the other thing is, how we define this new end-to-end acknowledgement after we discuss that we want it, which I'm not certain at all, but you have to convince me. Go ahead. And which is completely a new RFC, which describes this new mechanism in addition to the existing mechanism. So it's an end-to-end ACK as opposed to a local ACK or something. So we'll have to do two things. Both documents would be standard track and useful, etc. But this one just is the repository of the discussion that we're having to get there. Do we want to send that to the ASG? What would be the purpose?
Elevator tunnel routing AD. So I tend to somewhat agree with what you just said, which is if there's a document that sets up the discussion, there's probably not a need to publish that. Now, having said that, adoption of a document doesn't mean that it has to be published, right? I'm not the chair,
No.
but I think that having a stable discussion point may be important, right? With the understanding that maybe this is not going to be published at the end. Right? So we can balance all that stuff. And yes, please don't send to the ASG documents that shouldn't be published.
One more point that I just want to highlight here. So some of the work that the reason why we put out this document is because the implications it has on the storing mode of operations. And some of the implications might be sorted out by other documents, other work such as beer related work. It might have, so there should be some way of referencing the problems somewhere. So that this document might help in that sense.
Fine. Thank you. I will reiterate the request on the mailing list and see what the outcome of the discussion is. Thank you much for the comment. Then we have a remote presentation. Yes, possibly.
Hello,
Hello.
can you hear me? Okay.
Yes, I can.
I basically don't know how to change slides here. Do you change them or I haven't done this
Yes,
before?
next slide, and we'll do next slide. Okay.
Okay, okay. So hi, we have an update for our draft regarding an extension of the NSA node state and attributes in the metric container. Next slide, please. So in this version, we have published our implementation for Contiki OS, and I don't have the links here in the slides, but I can paste them in the chat room or send them to the email for all, whatever you prefer. And we have also published some Wireshark dissectors for the optional fields that we have introduced. But we have not included the compression, and I will discuss that a bit later. We have done rename some acronyms which were somewhat poorly chosen, and we have addressed. In this presentation, I'd like to discuss a few issues that have been raised. So, next slide, please. So I'll go over this material a bit quickly because we have presented that in the previous IETF. So this draft regards trying to achieve determinism. So as far as possible, as reliable as possible communication and low jitter. And in order to do that, we are trying to use packet replication and elimination. So doing multipath basically. And we also take advantage of promiscuous overhearing to reduce the costs for transmissions. Next slide, please. This draft specifically addresses the issue of alternative parent selection. So if you have multiple parents through which you can do packet replication, which parent you should choose to do that replication through. So we propose this extension to the DIO message in order to include information which will help towards that direction. Next slide, please. So the information used, which we will transmit in this extension, allows selecting an alternative parent which has some commonality with the default parent, so that the path doesn't diverge too much. So we are not. We could just use normally the second preferred parent, but we don't want to do it as simply as that because we are trying to contain the alternative path to be as close to the original one as possible. Next slide, please. So in this example, we have a sending node S, and he's trying to send some information towards the root at the top. And his preferred parent is A, and there is a potential alternative parent B. So the information that we are sending is information available to A and to B, the two parents in the parent set of S. So A will send his parent set, in this case D, C, and E, in that order, and B will send E and D. And now these are ordered in objective in terms of preference through the objective function. So that's why D is first and for A, and that's why E is first for B. Next slide, please. And the format, an example for the format of this information. So we are using the DIO message, and within the optional fields, we are extending the DAG metric container. Next slide, please. And specifically, we are adding within the node state and attributes routing type a optional TLV, with a type value which needs to be decided. The length is the size in bytes of the IPv6 addresses which we'll send, and basically the actual data we need to carry is the a list of IPv6 addresses of the parent set of a node. Next slide, please. So we have implemented this in ContiQOS, and we have modified Wireshark to be able to display it. Here at the bottom, I don't know, do I have a way of, no, of pointing somewhere? No. Okay, so at the bottom, you can see the expanded field for the node state and attributes routing type, and the raw data. It's a relatively simple dissector, but it works okay. Next slide, please. So the issues we would like to address, there are three of them. The first one regards the size of the information transfer. So normally it's 16 bytes per IPv6 address, and that's quite a lot. And to be useful, one would expect that at least 2 addresses should be sent. Otherwise, you don't have a possibility for doing any kind of real replication. So 32 bytes, it's quite a lot. So next slide, please. With a helpful pointer of Michael, we can use 6LoWPAN, the 6LoWPAN routing header. And in our case, all the IPv6 addresses contained in this extension are by definition belong to the same TODAG. So if we use the source routing header the compression for a source routing header, we can probably get to as little as 2 bytes per address, which is not insignificant, but it's probably not too much. And this is work in progress, the compression part using the 6LoWPAN routing header. We plan to implement it in Contiq. Next slide, please. A second issue we have to deal with concerns bad parents. So in this simple case, A needs to send his parent list, and it's D, C, and E if you order them by link quality metric. However, there is nothing stopping A from sending all these potential parents, although the link to E is pretty bad. So we would ideally want to avoid announcing parents which are relatively badly connected to a node. So we, with a helpful prompt of Oana, next slide, please. I think it's on. Next slide, please. Okay, yeah. We will just want to add basically a threshold on the link quality or whatever metric is used for ordering the potential parents, so that potential parents, parents in the parent set who do not fulfill this constraint are not sent at all. So this would cut out E in this example, so it is not sent. Next slide, please. Finally, there is an issue of flooding. So in the previous examples, we generally used a strict version of how to implement this constraint. So the strict version requires that the preferred parent of the default parent, so A is the preferred parent of S, and F is the preferred parent of A, that F is the preferred parent of an alternative parent. So for example, B1 has a preferred parent of E, B2 has a preferred parent of F, and B3 has a preferred parent of G. Out of these three, only B2 has the same preferred parent as through A. So using this strict implementation, only B would be an acceptable alternative parent for S. Next slide, please. There is also a less strict version, which doesn't require the equality between two nodes. It still uses the preferred parent of the preferred parent, again F. However, it does a comparison between sets. So in this case, we take the whole parent set of B1, E and D, the whole parent set of B2, F, D and E, and the whole parent set of B3, G and F. And if F is within any of these sets, then that's an acceptable alternative parent. So in this case, B2 and B3 would be acceptable, but B1, no. Next slide, please. Finally, there is also a more relaxed version, which would check if there is any intersection between sets of parent sets. So you take the parent set of A, the parent set of B1, B2, and B3, and if there is any intersection, then it's a potential parent. So in this case, all B1 through B3 are all potential parents. Next slide, please. So the problem is that the relaxed implementation, although it provides more options for replication, through experiments published in Ad Hoc Now 2018, and thanks to Thomas for that, showed that we have uncontrollable flooding. So that's a problem in terms of network efficiency. So our idea firstly is to use a medium or strict version so that we don't have so much replication. And there's also the idea of controlling the divergence through overhearing. So we'd like to control how many of the parents in the parent set actually forward the packets. And the idea is that we would use the parent set of, could you please go to the previous slide so I can show maybe. So here, the idea would be that when A broadcasts his parent set, so F, E, and G, F, E, and G, the same parents would also listen to the DIO message, and they would know that they are in the parent set of A. Now, we would control this divergence, but by saying that a fixed subset of these parents in the parent set would only forward in case of overhearing. So if a packet is overheard by either one of them, for example, E and F would forward as well, but G wouldn't, the last one in the list. So in this case, the first two would overhear, but the last one, no. Next slide, please. Next slide. Yeah. So we were wondering what the road forward would be for this draft. We have presented it more or less in the 3 last IETF meetings, and we have an extension addressing some of these issues on the way. We have received comments from multiple people, and Derek, Michael, Oana, and Thomas. And we have published this work in a journal and 3 conferences. So we are wondering if there is a path to adoption by the working group and what that would look like. Thank you.
You didn't mention that there is an implementation actually on this slide.
Excuse me?
You did not mention on the slide that there is an implementation.
In the road forward?
Mm-hmm.
I'm sorry, I mentioned it earlier in the presentation.
That's what I remember, yeah. Okay.
I'm sorry. Yeah, I should have.
Who read this draft actually? One person. 2. Who has read this draft? 1.5. 3 people. Okay.
Pascal Hubert, if I can insist on this one, we are talking about radio networks here, and it's well known, it's been well known for a very long time, that just using a wired type of thinking on those networks, where you just pick a shortest path or something, a best parent, causes high level of loss. You have a wireless medium, you need to think wireless. When you forward something, you don't forward to a next hop, you forward like up. Meaning that multiple nodes may overhear your packet, and that kind of compensates for the lossy behavior of the radio. And this particular effort is the first real thing that thinks wireless. We've been routing like if it was wire. Okay, we use an objective function which knows about radio, so we have ETX and all that sort of thing. But we still think next hop, next hop, next hop.
we don't think on forwarding over radio, my packet progresses if it reaches any of those guys in front of me, which are on the right direction. This is the first time in this working group where somebody introduces something which does that. And well, it's kind of a revolution if you look at it. And I think it's the right way of thinking this medium. So please pay attention. There is something happening here.
Thanks. So you recommend that you look at it more closely? Yes. Okay, thank you. We're coming back to you. Next presentation, please. You do the next slide.
Yes, it's me again. So for something completely different, we also have this draft, which is the definition of information and an objective function for this information for load balancing. Can I go to the next slide, please? So there are already, obviously, so a lot of this material has already been presented again, so I'll go a bit quickly over it. So we have existing objective functions, so which help determine the preferred parent, and there is also the load balanced objective function, which has expired, if I'm not mistaken, right now. Next slide, please. So the problems, at least with the standard objective functions, is that you don't have any kind of balancing for the network. Some might do more forwarding than others, at least at the same layer. You don't control for node lifetime. Some might spend up more energy than others, and at the same time you might get queuing, or which means both packet losses if the queue can't fit the packets, or at least higher delay. So next slide, please. We have a simple example here where all the nodes C1, C2, C3, and D1 have the same sending rate of packets. However, on the left, the network is unbalanced. So A receives 3 packets per second and B only 1 packet per second. And if you balance it, you basically need to reparent C3 in this example. Obviously, C1 or C2 would be good candidates as well. Next slide. Another example where all the nodes don't send at the same rate would be this, where you do have the same number of children for both A and B. However, the nodes themselves, the children don't send data at the same rate. So in this case, balancing them on the right would mean setting D2 just to B and putting all the rest on A to have a balanced transmission rate. Next slide, please. So this metric tries to send information, which is the packet transmission rate as calculated at each node. It's information that will be sent through the DIO metric container. And we haven't exactly decided how exactly to express this information, but the idea is that the objective function that will be able to use this information will select as a parent the parent which seems to be less overloaded, which seems to forward the less packet the fewer packets at this moment. So we have presented some preliminary results in the previous IETF. Next slide, please. And the structure is as before for the NSA extension. This is the DIO format, and within the DAG metric container, can I have the next slide, please? In this instance, we implemented it a bit simpler. We just created a new routing metric container type. I'm still not 100% sure which would be the correct approach, but in this case, we did it this way. And the information contained is the packet transmission rate. It's 2 octets, and it's just a number expressing how much the packet transmission rate at a node sending this DIO is currently. Next slide, please. So one issue highlighted during the previous IETF was what happens if you have if a node, given that there are neighbor table size limitations, what happens if a node cannot accept a new child to send packets through him? So Contiki, for example, uses 8 it can support up to 8 nodes by default. So if the parent has a full neighbor table, one option is for the parent to send a DAO ACK with a rejection status, just saying, no, you can't be my child. Or alternatively, we can integrate the packet transmission rate metric with a child count metric, and this way a potential child will know both the transmission rate of a potential parent and how many children it has, and this way they might opt to choose another parent who hasn't a full neighbor table. Next slide, please. Now, in general, these issues, what we have been working on seems to address two issues. One is parent selection itself, so it might have some relationship with replication as well, and load balancing. And we also have some upcoming work on DODAG selection and balancing, and we would like to see if there's a way of bringing everything together so that it's we can reuse some functionality and make it all somewhat more modular. Next slide, please. In this respect, as has been discussed in the mailing list relatively recently, there seems to be multiple points where you need to make a decision during the network life cycle. So when you join the network, you have some information in the EB packet, and then although there's no discussion about that specifically, you need to also change a Ripple instance, and then within that a DODAG, a specific DODAG, and we have a draft in progress for that issue. And then you also need to select a preferred parent. So the question is there a way of putting information in such a way so that it's available at each of these points, or somehow reusing it so that we don't address each issue independently? Next slide, please. Well, that's it, basically.
Thanks. Who has read this draft? One person. Okay. So what I will do, I mean, there are several drafts which have been presented here, which are personal drafts, and people, and the question is, are we going to take it over in the working group? In the working group, we already have a large set of drafts. There is this new beer work coming in. So I think the working group actually has enough on its plate, also seeing what is going on. So what I wanted to do is I will send out an email mentioning those drafts and ask who is interested to participate and work on it,
Okay,
next
thank
to
you.
what is already going on. Okay? Any
Okay.
comments on that? No? Okay. Thank you.
Thank you very much.
Thank you. This is a very old draft. It's the Mippel model. This is a very old draft. It's the Mippel model. I have received a young doctor's review. I have waited 6 months at least, and I have implemented all the changes to the young model review. What I added is a section on the network management data architecture. It tells you the structure of the model. I updated the description text, which was not very clear. Added units, because it was a bit vague if it was seconds, milliseconds, or anything else. So units have been added in the draft. I have had string modules, which are operations, seed, and statistics, which augment now a domain module, as was asked by the young doctor. And this is new. I assigned SIDs to the young identifiers to reduce the payloads. So that is the work which has been done. I'm all alone on this draft. I don't think this is very responsible attitude. I'm looking forward to co-authors, or at least people who review it and say things like, yes, this is what we want to measure in for young. So looking forward to reactions on that, contributions, and especially collaborative. And as long as I don't receive them, it will not go forward. Okay, comments?
Just one comment here. Rahul Jadhav from Huawei Technologies. Can this also be made use of for specifying the end node capability, what is required by DAO projection? What do you think?
Yeah, in Young you can specify a lot of things which are observable or settable. So if you have, for example, for the other drafts, I think there are lots of opportunities to add this kind of stuff in, and especially now that we have the SIDS, it gets much smaller, but it is an overhead. I mean, yeah. But I would recommend other drafts and not this one if you want to add operational measurements to the to what the other drafts describes. Yeah. No more actions. Then I think I'm going to leave the floor to our beloved friend Pascal, who will say something about another personal draft, which are the leaves. Okay.
Thank you, Peter. This is a draft that enables a node which is not aware of REPL at all to be a host in a REPL network. With the REPL specification, you have to participate to REPL to get routability back. We have worked hard at 6LoW to improve the 6LoW registration, 6LoWPAN neighbor discovery registration, so as to enable it as a way to register for various services, including routing back. And I will show you what we did and how that helps us at Roll. So basically the need that we are talking about is to be like any router, capable of serving nodes which don't understand our routing protocol, and that's something that was missing. The other thing is when you have a node which is deep into a network, you have a number of keep alives that you have to do. One is the DAO. You have to keep your route alive. Every lifetime you need to send a DAO, otherwise the state is cleaned up. At the same time, you have to send a DARDAC. The 6LR has to send a DARDAC on behalf of the 6LN so as to maintain the state for the duplicate address detection mechanism to work. So that means 2 packets which fly periodically all the way across the network, and there was a need to make only one. And then there is something which has always been there, and really, if there is one question to this group is, should we do it or not? In 6LoWPAN, there is a concept of a 6LBR. And the 6LBR, by definition in 6LoWPAN ND, is a border router. It's a function of a router. Now, if you look at what 6LoWPAN does with the 6LBR, it has only one role. It is a registrar. It is the place where you store all the addresses in your LoWPAN. So you wonder why a registrar in 6LoWPAN is called a 6LBR, and why it's defined as a border router when in fact all it does is a registry. The real border router in a REPL network is the root. Okay, so now you have this question, should the root be a 6LBR because 6LoWPAN defines that that's what it is, it's a border router? Or should the 6LBR be a separate entity, but then we should not even call it a 6LBR? So this draft has the flows to separate the 2 entities. In practice, I don't see that we need that at all. We could say, okay, let's make 6LoWPAN true and effectively make the 6LBR the REPL root. But it's kind of a design decision, because if they are not, we need to implement flows like are defined in this spec. Was I clear? 6LBR, root, same guy, not same guy. Okay, so if anybody can come to the mic and say, yes, it makes sense to separate them, or no, that would be useful. So basically, this draft addresses all that. This draft is, what if my 6LR, my 6LoWPAN router, is a REPL router? My 6LN doesn't know REPL, but now it understands the new 6LoWPAN ND. Can I do everything needed in REPL so that this guy gets his packets back? That's what the draft is about. So it runs in the 6LR mostly. The 6LN, there is nothing to do for it, as long as it implements 6LoWPAN ND. So let me just, in a few sentences, show you what 6LoWPAN ND what happened on 6LoopND and how that impacts our leaf draft. So the main biggest thing that happened on 6LoopND was Charlie's review. We went through all the ISG steps. I think we're okay. And we were in draft 19, and then Charlie came in, and since he's a co-author, and he did a lot of good editorial work, great editorial work. The draft is much more understandable, much more, well, the right thing at the right place, if you like, and obviously the English is much better now, it's not me writing it. But that changed the document quite a bit, so need to know that this happened. Then we actually changed the way we send the IDA redac, and that's not too important for REPL. What's more important is that we have made the 6LoopN registration agnostic to the routing protocol that you register to. Initially, 6LoopND was only to register to a 6 BBR, a backbone router. That's what was a big reason why we made it. Now we have two routing protocols, not one, but two, which actually refer 6LoopND and benefit from it. One is this draft, and the other one is Rift. And the key thing is, with 6LoopND, a node which does not participate to the routing protocol can indicate, for instance, hey, I was there, I'm here. You have a sequence counter, which is missing in most client to router interfaces. So now the routing protocol can inject the latest location of a device when it moves. So that's why Rift is actually keen on using 6LoopND. And REPL, well, I will show that we carry a number of information as well. So big change in 6LoopND, we don't refer to backbone router anymore. We refer to routing registrar, and that includes backbone router, REPL 6LR serving REPL leaves, and unaware leaves, and even Rift. So what did we change? To serve REPL, we already had the registration lifetime, which translates into the path lifetime in the DAO. We had the TID, which has the exact same semantics of the path sequence in REPL. And what we just added is this concept of an OPAC. And today with the 6LoopN draft, the way the OPAC is used by default when this I field here is 0 is it's a topology indication. If you do multi-topology routing, if you have REPL instances, then you can fit that here. Now the I field allows you to extend whatever you pass. The OPAC field is passed directly from the client to the routing protocol. It's opaque to 6LoopND. That's why it's called this way. 6LoopND doesn't care about the REPL instances. And the I field is just the way we signal what goes into the OPAC field. Okay, so that's the changes that we made in 6LoopND. So now what does a REPL router do out of it? So in 6550, a leaf already existed, and if you wanted a leaf to get packets back, it needed to inject its DAOs so that the route is known to the routing fabric. A leaf was only somebody who would not relay packet. So this new draft defines the REPL unaware leaf, which does not even send a DAO. The first router above it has to send DAO on its behalf. What the node does is just plainly support the RFC 6775 update. And the error flag in the update tells you whether you want your router to do REPL for you. It doesn't say REPL, it says any kind of routing. So the error bit triggers the backbone router or Rift or REPL, whatever the thing, the router that you're talking to supports. And now the big thing is, the big change in this version of the draft is that now we can use the OPAC field. Aligning to the change in 6LoopND, we can use the OPAC field to signal the instance ID. So that's the way you can have a node registering to a router and saying, hey, actually, if there is REPL above you, here is the instance ID that I want to use for my traffic. Now, there is another thing of interest which is not covered by this draft, and I would like people to think about it. If somebody gets access to a REPL network at layer 2, and we don't implement the security provision in REPL, which nobody implements, it's possible to inject any DAO with any address in there. Meaning it's possible to attract traffic to anybody and hijack this guy. With 6LoopND, we have a new mechanism called the rover. It's actually not in 6LoopND, it's in a child document called address protection, which allows us to put a cryptographic token associated to the address and use that as proof of ownership. There may be a way to use that to prevent injection of unlawful routes inside REPL. Do we want to look at that? So just a food for thought. I think we could, I think it's possible, and then REPL would be a lot more secure. And last but not least, there is this separation of the root and the 6LBR. So if we keep them separate, then there is this whole section in this document which explains what you do when. It's really a big question for this group. I really expect people to say, hey, one direction or the other. Do we merge the root and the 6LR, or do we keep all this text in the document? So basically what happens, oops, when a node registers for the first time.
There's a question from Jabber. Abdul Salam Baryung. Could this create a security problem, especially the non-REPL routing with REPL routing? Is that what you're trying to address here?
The previous, okay, Abdul Salam is talking about the rover field. The rover field right now is between the 6LN and the 6LR. It allows the 6LR to validate that the 6LN owns the address. And the question that I'm addressing is, since we are using provisions from 6LoWPAN to inject routes, could we also use those provisions to protect the routes? That's what, so. So yes, in this slide here, what you see is the initial exchange. A node forms an address, registers it to its 6LR with an NSRO. That goes with an extended DAR all the way to the 6LBR and back. That's how you do duplicate address detection. That's 6LoWPAN, just that with the new update, it's an extended, we have more information there, but it's the classical ND flow. After that, there will be a periodic DAO hack. And if you want to save sending the DAR again, all the way from the 6LR to the 6LBR, then what the draft does, it tells the root which gets the DAO, whether it's storing mode or non-storing mode, the root ends up getting the DAO, uses that to just keep alive the 6LBR. Since we're missing information like the rover, we cannot update it, but at least we can keep it alive. So that's what the draft says. There is provision for that. It's extra complexity. The question to you is, do we need it? And if you have a backbone router, you realize that the backbone router is all about routing. So the guy who needs to proxy the ND registration is not the 6LBR anymore, it's the root. So in runtime, when you have this guy periodically sending an NSRO just as a keep alive, the 6LR will send a single hop or multi-hop or single hop repeatedly, the DAO storing, not storing to the root. It has to be the root doing the proxy NS so that if a packet comes over the backbone, then the backbone router knows to pass it to the root, and then the packets can be forwarded. Then again, that creates this extra messaging, extra complexity between the root and the 6LBR that we can avoid. A single question for you. Do we keep all this text and explanation? Do we get rid of it? Should the 6LBR always be the root?
Any comments on the question of Pascal? Should we reduce terminology? I usually am in favor of...
Did we call for adoption on this thing?
No, we didn't. And it will enter in the same email. This. Who read this draft? 1, 2, the famous 2. Okay, so I will send, as I said, I will send out an email. There's a list of drafts. I will ask people if they want to contribute, read, or review the drafts. And it is a list, and we have already lots of work in this working group. So see what comes out. Okay, thank you. Good, open mic. Who wants to comment on how things are going, for example?
Rahul Jadhav, is there anyone in the room who is working on integrating Ripple with the Linux kernel or any other routing protocol? Linux kernel, basically integrating the Ripple, especially the routing table and the extensible, the extended header option that have to be added. I just wanted to have a discussion if someone is doing that, or any other routing for that matter, which any other routing which is integrated with the Linux kernel. Yeah, I've been to NetDev. Yeah, I was there, but they have not really started. But especially with the Ripple, there are some issues because in the data path you have to add that HBH option. That is not very straightforward to do. So that is where I have some questions. So if there is anyone in the room who can. Oh no, I have not talked about it. Yeah, it's not about the Ripple implementation per se, but it's about the integration of Ripple to the Linux kernel, which is a big deal. Which is where we are stuck, which we feel there might be some. Okay. I'll talk to him. Yeah, maybe I'll send out a mail on mailing list. Maybe. Yeah. Thank you.
Someone else wants to use the open mic opportunity? No? Okay, then I close the mic. And I thank you, everybody, for a very timely meeting. We are 8 minutes early. Fantastic. Thank you very much for all the contributions. And, well, to the next time. Thank you. No sheets. Yes, I didn't. Well, good dedication. I know, because it depends. Oh, you know as well, sir.